So that got my blood moving. I wish there were 10 minutes in between so I could yell at you guys about how I feel about all the stuff that you've all just told us. But you'll get more chance to hear my whining and complaining in a good way later on. Next up, to try to keep things moving, is Todd Traver from Uptime. And Todd's going to talk to us about 5 edge data center myths. Todd, are you in the room? All right. Let's welcome Todd.
Okay, good afternoon. Todd Traver, VP of IT Optimization and Strategy for Uptime Institute. And so there were some really interesting slides that you've all had, so I'm going to be able to go through some of mine pretty quickly. My focus today is going to be on how do you keep the edge data center operating, and some of the lessons learned that we've seen in enterprise data centers, other data centers that we feel are very applicable to the edge environment. The edge is really just another form of data center, and so how do you manage it? How do you design it? How do you operate it? How do you keep it up and going? So what we're seeing in edge, because of the criticality of the applications, the technologies involved, that the edge data centers are as or more important in some cases than the enterprise data centers. So we feel they need equivalent focus. So I'll take you through some slides, some background, and then the approach we recommend that organizations take. Okay, so where is the edge? I can see this is going to be interesting because different people have different views of where the edge is, and how do you keep it up and operational? So, in our view of the world, is the edge is a device that generates the data. So, if you look at the Internet of Things, the things part is the edge, and then you take it from there. It starts to summarize some data, and it's really end user focused. So, how do you gather data from the sensors? How do you provide a better quality of service, quality of experience to the end user? And we see it taking many forms. There's a lot of edge-like work being done in co-location and enterprise data centers today. We see that moving to other form factors. Micro-modular data centers, modular data centers, you name it, there's all different types, but they all need the same rigor in terms of engineering design, electrical, mechanical cooling. But now you have the factors of the network is even more important to an edge data center because that's how they're operated, is remotely. So there needs to be additional focus on network. And the facility design itself. So I'll take you through a couple slides and some of our thoughts on that. Why is the edge important? It's already been mentioned, but basically it's moving the function closer to the end user. It's really moving the cloud to the edge, closer so you can get higher bandwidth, better response time. It's also a new source of data, new source of mining information. So we feel there's going to be a lot of demand, driving these new instances, again, in the different form factors. And as Yuval mentioned, the other thing it does is it separates the end user experience, from the centralized computing. So I'll show you a layered model of, how, Uptime Institute and 451 Research see this evolving and the functions that each of the layers plays, and how does this all tie together? How do you design then, knowing it's going to be a multi-tiered architecture? What are all the elements that are needed? And, the success of all the elements working together, is really, the critical factor for edge data centers. So this is similar, a little busy of a chart, but, the edge is evolving. What we're showing here is the different types of workloads. And so what you're seeing here is a traditional, edge today, like a Netflix. So it puts content close to the user, but it's really not very critical. Latency, not that big of a factor. But where things are headed rapidly is to the upper right-hand corner, where the applications are very critical, and they really have high demands for low latency. So, you've all mentioned, self-driving cars, 5G, all the things that brings. We see, a lot of the networking capabilities being driven up into the edge. So That needs very, very quick response time, high bandwidth. The only way you can accomplish that is putting the actual IT kit closer to the user. And so really the focus is, how do you maintain, since it's such a critical environment in terms of reliability, criticality, latency, how do you keep this all going? And what there are is now more than ever more moving parts in the system. And so there's really more things to keep an eye on. This is a busy chart, but the point on this is, depending on who you are, the edge will be different things to you. So, in the case of IoT data center, it could be a full-blown enterprise data center. If you're a distributed cloud, you may well be running in a micro-modular data center. Smart industry, they very likely are running some type of converged appliance. So all the compute, storage, network built into a box out on the manufacturing floor. And then finally, connected vehicles. The 5G cell phone towers are really going to be the drivers for that. So it's really, how do you manage all of these different environments? How do you have one approach that you can address all of these? So that's really what I'm going to be focused on. Okay, here's it's not really a schema, but it's kind of how things operate. So starting at the bottom is what we consider to be the edge, and that's really the thing. So it's smart cities, smart business, you name it. It's any of the sensors that are out there gathering the data. That then flows up to the near edge, where it's really aggregated. There's some metadata created, some functions that are built in there, and a lot of it then flows back, to the hyperscale data centers. Really, what I'm going to be focusing on, you see the red oval of the different types of facilities, and how do you plan for those? What are the elements? We've identified, like we said in the title, 5 basic elements. So I'll take you through each one of those, what we consider to be critical success factors. Okay, so the increasing importance, everyone's expectation is it's always on, it's always available, it's low latency. I mean, that's just, we all have smartphones, that's just what the expectation is. Uptime's business is making sure things run and are available. And so how do you design that in? The trick here is, again, there's a one size doesn't fit all. There's all different form factors. So how do you design or make sure it's designed properly? The electrical systems, the cooling, the networks to control them. I mean, all of those things are critical for the successful operation. And then the thing we're seeing now with edge is, they're obviously location dependent. They need to be near where the users are, which may not be, and likely isn't, in many cases, an ideal place to put compute. So how do you plan for that, especially given the weather that we've had lately with the extreme highs and lows of temperature, flooding? How do you roll all that in and make sure you have a critical facility, but one that's subject to different kinds of risks than many of the traditional data centers see? So one of the things Uptime has come out with is tier ready, for the modular data centers. So that's basically a pre-certification of the electrical and mechanical systems within the enclosure. We feel that additional certifications of that type are really needed at all the levels to make sure you know what you're getting, is really what it amounts to. There's there's the same complexity, if not more, in these small data centers than there are in large data centers. And the trick here is they're running remotely, so you don't have people that can, oops, if you had a gap, you can make up for it on the fly. These have to be properly designed to basically run themselves. So are you ready for the edge? Uptime Institute does an annual survey, and 40% of the respondents had said they are moving to the edge. They have some demand for it. We've seen similar results from 451 research, so it's here, it's coming, it's getting bigger, faster. And so how do you get ready for it? But at the same time that people are quickly moving to the edge, and I mentioned all the complexities and things you have to deal with, what we're seeing on the enterprise side is 31%, so almost a third of the people have had an outage this year. So that's like with one data center, staff on hand, properly designed, and they still have problems. Once you get all of these smaller data centers operating remotely, we expect, you could have similar outages. So you really need to put the same rigor into designing and implementing these, the smaller data centers, than you do the big enterprise ones. The good news is that of all of the 31% that folks that had outages, 77% of the people, once we go back and interview, we track the outages, what caused it, what was the root cause, how could it have been avoided. All of the respondents had said, 77% said it could have been preventable. And so what we're focused on here, and the 5 elements I'll take you through, is how do you prevent it? You can see the percentages of the failures. Network is almost a third, which is going to be key. So that's kind of an inconvenience. If you have an enterprise data center, it's more than that. But if you have an edge data center, you've lost connectivity to that center. So that's a real issue. IT software error. We're seeing a lot of people that are using software resiliency to really augment the physical resiliency. So the applications will roll from one cell tower to another, one box to another, which is good, but that also needs to be carefully planned. So how do you ensure that's in place? To avoid some of the power problems, we're seeing a lot more focus on generating power at the sites, little micro cells and things like that to support these, so they don't have the same exposure to the grid. So there's a lot of considerations when you put an edge data center in place, and I'll take you through some of the ways you can do that. So here are the 5 areas. We feel, first and foremost, it needs to be properly designed and built. So Uptime, when we certify a data center, we spend the majority of our time working with the organizations in the design, before they actually build it. Make sure there aren't any gaps. So we need to do the same for these. Management and control. How are you going to operate it remotely? How do you test it? How do you make sure it works? So again, we found the majority of the outages, are actually operator error. Now it could be automation error. So how do you factor that in? The network I mentioned, that's critical, more so than ever. The facilities infrastructure, that's the electrical, mechanical. We'll talk a little bit about that. And then finally, how does IT resiliency kind of tie it all together? What are the components to that? The thing we're seeing more than ever with edge data centers is it's really a comprehensive design. So there are multiple elements that need to work together to produce the resiliency, because you talk to a lot of folks and say, well, if I lose one site, the other one will continue, or the software will roll over. It will if properly designed, but you need to make sure that that's all the interlocks are in place for that to happen. A lot of things, there's a lot of critical path items, there's a lot of complementary components, a lot of interdependent functions. So again, even more so with the edge data centers than with enterprise. So how do you work your way through that? That's some of the focus items. I mentioned management and control. The big challenge we see here is really the no on-site staff. So what type of control systems do you have in place? What kind of automation? You've all mentioned like 1,000 instances, which is easily possible across the United States. How do you manage that? So we really see machine learning, AI, it needs to be self-managing is what the answer is. Within the terms of the way the data center is constructed, there needs to be a lot of built-in redundancy. So again, the electrical mechanical systems, the IT systems, and network systems, all of them are complementary to each other, all need to function together. And because of the scale and the scope of it, we see that autonomous operations are really what's required. You can't have a staff managing manually in any way this quantity of sites. So there needs to be a solid focus on that. Network, obviously, this is the glue that holds it all together. There really cannot be any single paths, single points of failure. You need to have the concurrency built in, and what we see more than ever is you need to plan it, as I mentioned at the beginning, and then you need to test it. And that goes for all this. The 5 elements I mentioned, where we see most of the problems in enterprise data centers is each component individually works fine. When you integration test them and then fail one, it should have failed over in such and so fashion, but it didn't. So we see like a cascading problem. So, we think it's important that, the network is tested with the facility, is tested with the software, and there's an integrated testing plan, really. The facility's infrastructure, I mentioned before, definitely no allowable downtime. So, the expectation is it's always going to be available, always going to be responsive. And to accomplish that, we feel that the redundancy is really critical to the success of this. So, I mentioned the tier ready. It's essential that the facility can take care of itself. Send an alert that something's going bad, swap over to the redundant component, until you can get a tech on site to fix it. So we see the only way to really accomplish that is through redundancy. What we've seen, through our experience with enterprise data centers and other data centers we've dealt with is you really need to know your design and test your design. So a lot of the customers we've dealt with enterprise data centers, they say, well, it should function like this, but I've never actually tested it. In these cases, we really feel you do need to test it, that everything works together as it should. You don't have any failures. The key to all of this is identifying any weak points, and once you identify them, fix them before they become a problem to you down the road. So that's a high-level view of the elements, the critical elements. We feel I have details behind each of these, but these are really the takeaways of what need to be focused on. We see the IT resiliency is really augmenting the physical. So if the data center does have a problem, the software can fail over, the hardware can take care of itself to a large degree. It can switch over to alternate platforms. What we see is being able to do that, you're going to need to be able to actively monitor it and actively, and it'll need to react itself. You can't be counting on, human intervention to, oh, we're having a problem in edge site, 1, 2, 3, so let's switch it over. It really needs to do that itself. And really the way to accomplish that is based on our experience with enterprise data centers. You need to have a regular testing schedule. So, you see a lot of the same things, but again, these are small data centers. They really need to have the same rigor, same level of testing, if not more so. So I'm going through this quick, but really, so the takeaways are, we feel it really needs to be an end-to-end, comprehensive design. So it's not just, oh, I'm going to buy this modular data center from, producer XYZ, I'm done. You really need to integrate, how is the network going to be planned? How are you going to operate it? Where is it going to be installed? All of those considerations. The complementary elements working together, that's really where we see the resiliency and reliability, coming from the edge data centers. It's not, oh, my electrical system will never ever fail because it will, or my cooling will never ever fail because it will. It's how does, when one fails, how does it roll over? How is it backed up? And how is it, caught by other components? So we feel that the experience we've gained and can provide in terms of enterprise computing is really applicable to edge. This is nothing really new. It's different, but it's not new in terms of what are the basic blocking and tackling required to keep it going. So, what we would recommend is a formal review, however you choose to do that. Make sure that you understand how the system will perform, and then really track that over time. So those are the major elements. Those are the five elements. So uptime for our tier ready. Tier certifications, upper right-hand corner. We now have tier ready, upper left-hand corner. So that's for the small modular data centers. M&O we do, which is the operations piece. So these are all applicable directly to edge data centers. And then as well in the center, and really kind of what I'm talking around here without giving any real deep dive into it is, how do you manage this hybrid resiliency? How do you assess how resilient your operation is? What are the factors you need to look at? So that's a new one that we've added to our portfolio. So with that, that's really where we are. It was a quick tour through. You've all covered a lot of the technology. I just wanted to give you our perspective on the 5 major elements. Any questions or? Sure.
I haven't heard anybody talk about DR.
Yeah.
You're talking about not being able But DR means I got the data somewhere else.
Yeah, no, DR is critical. I mean, a lot of these will be used to some degree for DR. I mean, so they have they're able to synchronously replicate. They have 7-second or less, microsecond or less latency. So we're seeing a lot more people using Edge for a form of DR, moving VM systems and the like. If that answers your question, but we're seeing them used in that fashion as a portion of DR.
DR for an edge. If I've got an edge computer center or anything, I have a disaster at that edge. How have I replicated stuff to another location?
Okay, so in terms of, I would say in that case, that's part of the planning you need to do so edge data is moved back up towards the cloud. So I would say the cloud is probably the ultimate repository at the back end, and that's probably a big piece of your DR. Yeah. Yeah.
If you look at utility-based edge deployments, I'm curious what Uptime may be doing in that front to look at the supply chain of energy creation and distribution upstream of data centers.
In terms of, okay, I'm just.
Utility A, utility B.
Yeah, right.
Here's a grade for you, here's a grade for you.
Okay. I think what the edge data centers need to do is very often they don't have the luxury of two utility providers, so they're stuck with one, whoever it is. And that's why I mentioned in some cases they're just doing self-generation. And with these smaller implementations, 100 kilowatt, 150 kilowatt, it's much easier to do. So you pretty much, you have to put these edge data centers where they're needed, and you pretty much have to live with whatever power you can get. And if it's not good enough, you need to generate your own, really. That's what I would say.
All right, we got time for
Okay, I'm sorry, yeah. Sure.
Regarding could be a co-location edge facility or an internal edge facility, how do you manage to be cost efficient? Because the edge is smaller, you lose some scale economy versus the
Right.
So is the edge actually more expensive?
The honest answer, I don't know. I would suspect it's probably incrementally more expensive. I bet you we'll learn more about that this week. But you're right, because a hyperscale data center is brutally efficient, which is great. And then so how do you have these little instances and how, on a cost per, MIP or something like that? How do you make them as cost effective? I don't know. Perhaps 451 has some information, but I'll find out. Contact me afterwards. I'll get you an answer.
Yeah, because you're trading off performance latency.
Sure.
Right, so the trade-off comes with a cost.
Oh yeah, right. No, there's a cost, and I would expect there's going to be a bit of a premium for edge compute versus, say, hyperscale, and then there's a lot of things in the middle. So it's, and all of this, and then I'll kind of close with this, is, you don't implement an edge strategy unless you need it, but more and more people are needing it. So it's all part of the cost equation. So they're moving some of the function and data, sharding it perhaps, pulling some of it to the edge, and maybe, their enterprise data centers are a bit smaller than they used to be. But yeah, so anyway, I'll get you an answer on the cost. I don't know.
Great. Well, folks, thank you.
Right, thanks.